All right, this is a video sort of walking through the thought process behind our question 2 in our covariation CYU, the one that involves the skateboarder on a half pipe. Now, with this one, I am going to give you a little warning. My graph is going to look slightly different than the graph you will see in the CYU solutions, and that's because I'm basing my graph partly on the video I'm going to share with you, which adds a little more detail to what might be going on in this skateboarding situation. But I find it really helpful to watch the video. I'm not a skateboarder. I don't normally watch skateboarding. So what a skateboarder looks like on a half pipe is not something I really am familiar with. And so the video sort of helps me think about it in my mind as I'm trying to think about how the horizontal distance from the starting point varies as time goes by. So that is the two quantities that we want to relate. So before we get into this, I'm going to just have us watch this video, and then I'm going to talk about how the video relates to these quantities. And in this video, what you're going to see is I ran the video through once on normal speed, and then I slowed it down. And I will post a copy of this video separately. So if you want to just watch this video as you work through your CYU, that's fine. But then I also wanted to show it here where I can sort of talk through my thinking as I sort of see the video. All right, so here's our video. The quality is not great, but again, the idea is to help us think about, we're tracking the horizontal distance of, the skateboarder as time sort of progresses. So the skateboarder, notice, when we get to one end, the skateboarder shoots sort of straight up in the air and then sort of comes back down. Okay, now here we're going to slow down the video a little bit because it goes really quick. Okay, notice right away the skateboarder gets almost straight down to the bottom of that half pipe. It doesn't take much time. And yes, he traveled a great distance, but the horizontal distance where he is at this moment from where he was at the beginning isn't much. His horizontal distance didn't change at all, really. Okay? And almost now in the same amount of time, he's halfway through that half pipe. And now his horizontal distance is huge. So in that next moment, his horizontal distance increased a lot for almost the same amount of time going by. And then we're going to see sort of a similar trend on this other half. His horizontal distance is going to increase a lot as he's on the bottom of that half pipe. But when we hit this wall over here, his time is going to keep going, but his horizontal distance isn't really going to change much when you're sort of on that flat side of the half pipe. And I like to talk about when he's in the air. And this is the piece that's sort of missing from our CYU solutions. When he's in the air over here, when he has air time, if he's doing this correctly, his horizontal distance from that start is not changing at all. But again, time is going by. So what we're going to find here is we're going to get little sort of flat parts to our curve there at the top where, his horizontal distance is constant, but time is still moving by. Now, all of this is in like quick moments of time. Like this is instantaneous almost, fractions of a second. And then it repeats as he goes back to the other side and we get that air time. And then, and so we can sort of think about this. Now let's go back to the diagram. Oops. So, when we think about this sort of from here to here, his horizontal distance increased just a teeny little bit. And that didn't take very long. And it probably took him just as long to reach this horizontal point, and sort of we can sort of split up our curve. And then I like to think we got our air time on either end. So if I'm sort of splitting up amount of time elapsed, we're going to sort of call this like A, B, C, D, and then there's my sort of E over here. A, B, C, D all sort of took equal amounts of time. But initially, my horizontal distance isn't increasing very much. Now, for each little bit of second that goes by, his horizontal distance is going up a little more sort of each as that sort of, we reach the bottom of the thing. So we are going to have a slight curve, where, my horizontal distance is going to be changing by a little more as each second goes by. But then when I hit this middle part here, my horizontal distance is going to be increasing a ton. And then same thing goes sort of for this next piece. Again, our horizontal distance is increasing by a lot to get to the far end. But then we sort of hit this other curve over here. And now from C to D, for each sort of, second that goes by, my horizontal distance is going to increase by less and less and less. And so we're going to have sort of a flattening off. And then, in that sort of moment, so this is like D, in that moment E, we get a sort of flat piece where I like to think of this as your air time. And then we're going to repeat but we're going back towards the start. So our horizontal distance from that starting point, we're going to be getting closer and closer. So that horizontal distance is decreasing, but initially the amount it's sort of decreasing by is going to get more and more and more. And then when we hit that flat part, it's almost going to be constant as we sort of work our way back to point A. And then it's going to get, decrease by less and less and less as we sort of get back towards that starting point. And so, we're sort of back at our other point D, it curves. And then it's sort of a constant. And then we sort of flatten out, and then we have our air time on the other end, and then the pattern would sort of start again. And so you can sort of see, what's going on here, in that middle area for those equal changes in time, our horizontal distance from the start was huge. That was a huge, it took, the same amount of time to get from A to B as it did to get from C to D. But that horizontal distance was significantly less on C to D as it was from A to B. And that's really the key here. Whether or not you can argue like those flat air times should be there or not. But the general idea is thinking about that horizontal distance increasing. Again, just like with the previous one, you could, go back in that CYU solutions and read the written description. The idea here was sort of, how was I looking at the video? How do I sort of break this into chunks? What's my thought process behind it? And hopefully this gives you a sort of point to start from and maybe gain a better understanding of this situation.